Hello, in this lecture we will find the radius of a circle. In the drawing we have a circle and the center of this circle is at point O. Inside the circle we have a rectangle and also this line segment equals to 6 units and this line segment equals to 3 units. And we want to find out the radius of this circle. First of all, we define this point as point M. So line segment CM equals to 6 units, and we will define this point as point N. So actually line segment AN equals to 3 units, and we will also define line segment OM as Y. So OM equals to Y. And we will define line segment ON as X. Or ON equals to X. Okay? OM equals to Y and ON equals to X. Actually, OC is the radius of this circle because of the fact that line segment OC starts from point O, that is the center of this circle, and ends at point C, that is a point on the circle itself. For that reason, line segment OC is the radius of this circle. So actually, OC equals to Y plus 6. OC, that is the radius of this circle, equals to Y plus 6. Okay? So OC equals to the radius of this circle, and it also equals to Y plus 6. Okay? So line segment OC is the radius of the circle, and it equals to Y plus 6. Y plus 6 is equals to OC, that is the radius of this circle, and also OA is also the radius of the circle because of the fact that it starts from point O, that is the center of the circle, and ends at point A, that is a point on the circle itself. So OA is the radius of this circle. So OA equals to R, the radius of the circle, and OA also equals to X plus 3. X plus 3 equals to OA. Okay, so actually OA is the radius of this circle because of the fact that it starts at the center of the circle, that is to say point O, and ends at point A, that is a point on the circle itself. For that reason, line segment OA is the radius of this circle. Any line segment that starts from the center of the circle and ends at any point at the circle is defined as the radius of this circle, and line segment OA satisfies this definition of a radius of a circle. So actually, OA is the radius of this circle, and it also equals to X plus 3. Okay, OA is the radius of the circle, and so it equals to X plus 3. And OC is also the radius of the circle, and it equals to Y plus 6. So actually, OA and OC are equal to each other because both of them equals to the radius of the circle. So we can write down our first equation that states that OA equals to OC. OA, that is the radius of the circle, equals to OC, that is also the radius of the circle. Both of them radiuses of the circle. So they are equal to each other. But we know that OA equals to x plus 3. So we can substitute OA in the first equation by x plus 3. And OC equals to y plus 6. So we can substitute OC by y plus 6. Okay? So we got equation number 1 that states that x plus 3 equals to y plus 6. We will substitute 6 from equation number 1. So we will get that y equals to x minus 3. Okay, so actually x plus 3 minus 6 equals to x minus 3 because 3 minus 6 equals to minus 3, so x plus 3 minus 6 equals to x minus 3, and y plus 6 minus 6 equals to y. So in total we get that y equals to x minus 3. Okay, y equals to x minus 3. So actually, because of the fact that this is a rectangle, so if side OM of the rectangle is y, side OB is also y, because the parallel sides in the rectangle are equal to each other, and also all the angles in a rectangle are 90 degrees. So actually this angle ONB is also a right angle. It equals to 90 degrees. So side NB of the rectangle is y because it equals to side OM that is also y. But according to equation number 1, y equals to x minus 3, so we can add here that y equals to x minus 3. And actually OB is also the radius of this circle. Okay, add here that OB equals to r. OB is the radius of the circle because of the fact that its line segment OB starts from point O, that is the center of the circle, and ends at point B, that is the point on the circle itself. For that reason, line segment OB is the center, is the radius of this circle. So OB is the radius of the circle, but OA is also the radius of the circle, and OA equals to x plus 3. OA equals to x plus 3. So OB, that is also the radius of this circle, will be equal also to x plus 3. Okay? Actually, both OA and OB are the radiuses of this circle, and OA, that is the radius of this circle, equals to x plus 3. So OB, that is also the radius of this circle, also will be equal to x plus 3. Okay, so if we look now at the right triangle ONB, the right triangle ONB in the green color, We know that the side ON of the right triangle ONB equals to x, side BN equals to y that equals to x minus 3, and the hypotenuse of this right ring triangle equals to x plus 3. So we actually can use the Pythagorean theorem in order to find out the value of x. Okay, so according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the square equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to ON square plus BN square. Okay, so equation number 2 will be the implementation of the Pythagorean theorem in our right green triangle. So according to the Pythagorean theorem, in the right triangle, the square of the hypotenuse, that is to say OB square, equals to the sum of the squares of the perpendiculars. The sum of the squares of the perpendiculars are ON square plus BN square. Okay? But we know that OB equals to x plus 3. OB equals to x plus 3. ON equals to x. And BN equals to x minus 3. Okay, again, OB, the hypotenuse of this right green triangle is x plus 3, and O is x, and NB equals to x minus 3. So we can actually put the data in equation number 2. We will get that OB square is x plus 3 square equals to ON square, that is x square, plus BN square, that is x minus 3 square. X minus 3 square. Okay, so we got in equation number 2 states that x plus 3 square equals to x square plus x minus 3 square. We will open the brackets in equation number 2. So we will get that x square plus 9 plus 6x equals to x square plus x square plus 9 minus 6x. So actually, we open the brackets in equation number 2. X plus 3 square equals to x square plus 9 plus 6x, according to the formula that a plus b square equals to a square plus b square plus 2 times ab. So we got that x plus 3 square equals to x square plus 9 plus 6x, that equals to x square, and x minus 3 square equals to x square plus 9 minus 6x according to the formula that a minus b square equals to a square plus b square minus 2 times ab. Okay, so actually we have x squared in both sides of the equation, so x squared is cancelled. We have 9 in both sides of the equation, so 9 is cancelled. So we actually left with in this side of the equation we left with 6x, and in this side of the equation we have x squared minus 6x. So again, in this side of the equation we have only 6x, and in this side of the equation we have x squared minus 6x, x squared minus 6x. We will add 6x to both sides of the equations. We'll subtract 6x from both sides of the equation. So we subtracted 6x from both sides of the equations. So 6x minus 6x equals to 0, and x squared minus 6x minus 6x equals to x squared minus 12x, because minus 6x minus 6x equals to minus 12x. In the next step we will take a common factor x from the second equation. Again, we will take a common factor x from the second equation. We'll get that so we took common factor x from this second equation. We got that x times x minus 12 equals to 0. Actually, we have two solutions to the second equation. The first solution, x equals to 0, is impossible because x is the side of the rectangle. It can never be 0. The side of rectangle must be a positive number, so this solution is impossible. And the other solution to this question, to the second equation, is x minus 12 equals to 0. Okay. So if x minus 12 equals to 0, then we will get that x equals to 12 units. Okay, x minus 12 equals to 0, so we can add to the second equation 12. We will get that x minus 12 plus 12 equals to x, and 0 plus 12 equals to 12, so we got to the equality that x equals to 12 units. But we know that the radius of this circle equals to x plus 3. Okay, x plus 3 is the radius of this circle. So the radius of this circle equals to x plus 3. that equals to x, that is 12 units, plus 3 is 15 units. So the radius of the circle equals to 15 units. That is our final answer to the question. So the final answer to the question is that the radius of the circle equals to 15 units. Okay, the radius of this circle equals to 15 units. Now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. Inside the circle we have a rectangle, and the center of this circle is at point O. We know that line segment MC equals to 6 units and line segment NA equals to 3 units. And we define the line segment OM as Y and line segment ON as X. And actually OA is the radius of this circle because it starts from the center and ends at point A, that is a point on the circle itself. So OA is the radius of this circle, and OC is also the radius of this circle because of the fact that its line segment OC starts from the point O, that is the center of this circle, and ends at point C, that is a point on the circle itself. For that reason, line segment OC is the radius of this circle. So actually, because of the fact that both OC and OA are the radiuses of this circle, we can say that OC equals to OA. That is our first equation, that OA equals to OC. But we know that OC equals to Y plus 6. Okay, so we can substitute OC by Y plus 6. And OA equals to X plus 3, so we can substitute OA by X plus 3. Okay, we can substitute OA by X plus 3, and we can substitute OC by Y plus 6. So we got in the first equation that X plus 3 equals to Y plus 6, and we got that Y equals to X minus 3. Okay, Y, that is the side of the rectangle, equals to X plus 3. So if this side OM of the rectangle is Y, then the parallel side must be equal also to Y, because the parallel sides of a rectangle are equal to each other. So if this side is Y, this side is also Y. But we know that Y equals to X minus 3, so we can add here that Y equals to X minus 3. And we also know that the radius of the circle is X plus 3, and OB is also the radius of this circle because it starts from point O, that is the center of the circle, and ends at point B, that is a point on the circle itself. So OB is the radius of this circle, and therefore it equals to X plus 3 because this is also the radius of this circle. So OB, that is the radius of the circle, equals to X plus 3. So we have OB that equals to X plus 3, and ON equals to X, and ONB equals to Y, that is X minus 3. So in the right triangle ONB, we can use the Pythagorean theorem in order to find out the value of X. This is a right triangle because all the angles in an rectangle equals to 90 degrees. So angle ONB equals to 90 degrees. For that reason, triangle ONB is a right triangle, and we can use the Pythagorean theorem in order to find out the value of X. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. OB square equals to ON square plus NB square. Okay? So according to the Pythagorean theorem, OB square, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars. That is to say, equals to ON square plus bn square. But we know that OB equals to x plus 3, and O equals to x, and bn equals to x minus 3. So we can substitute OB by x plus 3, we can substitute ON by x, and we can substitute bn by x minus 3. Okay, so we solved the second equation that states that x plus 3 square equals to x square plus x minus 3 square. We solved this equation and we got to the final result that actually x equals to 12 units. So we know that x equals to 12 units, but the radius of the circle is equals to x plus 3. So the radius of this circle equals to x plus 3 and x equals to 12 units. So in total the radius of the circle equals to x, that is 12 units plus 3. So the radius of this circle equals to 15 units. Okay, the radius of this circle equals to 15 units. That is our final answer to the question. The radius of this circle equals to 15 units. Okay, thank you very much.